What is up, everybody? Phantom Darkness 135 here. You guys have been asking for a new programming tutorial for quite some time now, and I'm really sorry about the delay. I wanted to get something that would be really fun for us to do, and our previous ones were back when I was a student, and I feel like I've grown at least a little bit as a programmer since then. And I got a lot of feedback from the previous programming tutorial, so I'm going to try to implement that feedback here. And we're going to do this one a little bit differently than the previous ones. The first change is going to be that instead of typing this with you guys, I have the code all written out, and I'm going to give you the code fully commented and everything. And right now in this video, all we're going to do is go through it, and I'll explain what's going on in the code. I think this is more practical for you guys and a lot faster than me just typing out the code from scratch with you guys. And plus, you don't have to listen to my annoying keystrokes all the time. So, before we get started, we are, as you can probably see from the left, going to make a Hangman game today using the programming language Java. You guys specifically asked for a Java tutorial because a lot of you guys are picking up Java, which is awesome. I highly recommend digging into some Java books or resources online and continuing on with it, because programming is it's a lot of fun, first of all, and it's just practical. No matter what you do, you can use programming in your field. All right, I'm coming off my soapbox now. That's all I got to say about that. I will say that I'm going to assume that you have just a little bit of programming experience. If you don't, that's okay too, but you might fall behind here. If there is a concept that you are confused about, feel free to leave a comment, and I or another programmer in the YouTube community will try to answer your question. Or don't underestimate the power of a simple Google search. A lot of resources are available on Google, and you can probably get your question answered there. But if there is something in this video that you do have a question about, feel free to ask. And I'll also add the caveat that this is not going to be the most efficient program. I'm not making that promise because I am not perfect. I still have a long way to go as a programmer myself, especially with Java, which I do not program in that often anymore. So the reason for this video is not to give you a perfect product, but to give you something that you guys can play around with and tinker with the code and add to it and make it better and make it to suit your needs. So with all that in mind, a couple weeks ago I got together and made this Hangman game, and I tried to make it as customizable for you guys as possible. So I'm going to give you all the pure code. You are free to do whatever you'd like with it. And I'm also going to give you the images that I used and made for this. But you can also make your own. So enough talk. Let's get started and take a look at the project. I guess the first thing we should do is see what the end product looks like. So we're going to go ahead and run our project. I am going to be using NetBeans in this tutorial, but you can use the compiler of your choice. If you run into any problems with that compiler, just leave a comment and we'll see if we can figure the problem out. So when we run the program, the first thing that comes up is a little dialog box to ask you to death, to ask you the password that you want to be guessed in the game. I'm assuming you also know how to play Hangman. If you don't know how to play Hangman, now might be a good time to pause and Google Hangman so you know how to play. So let's just do Phantom. It is called Phantom Hangman just because. And we can either quit or play. We're going to play. And so these are all, we could have implemented these letters just as characters, but I decided to make images for all the letters because I think it looks a little better. You know, I'm not very artsy at all, but, you know, a little bit of images and some paint, MS Paint goes a long way. So this is our Hangman picture. I guessed right because I guessed an H. And then if I try to press H again, it won't do anything. So that's good. And now I'm going to guess J, which is wrong. So we get a head, a very worried looking Hangman head. How about C? Now we get the body. K, E. All right, let's go ahead and solve it. T, O, M. And we'll see what the win screen looks like. You win. So then when you finish the game, no matter if you win or lose, it'll tell you what the password was. And it will ask if you want to start a new game. You'll notice that also we have the word up here in the top, how much they've guessed so far, and the amount of incorrect guesses. I think I have it at 6 incorrect guesses is a losing game. So we would not like to start a new game, so we're going to leave that. I'm going to go ahead and show you what the images look like. Right in here. I have this under old programs, but it's actually a new program. Anyway, so I just made these in MS Paint and saved them as PNGs. So it actually took me a long time to make all these letters, right? And to do the, I made them opaque so you can see what they look like when they're big. And they looked really nice when I did them big like that, but in the game they kind of look, I don't know, I don't think I like the way they look at them. So if you guys want to make your own pictures, feel free to do so. The important thing to see here is how I named them, because, and you guys can change this in the code, but as the code stands, it's easier if you name your images, if you make your own, the same way. So the regular letter is just the letter .png. When it's guest, it's an underscore followed by a lowercase guest.png. And then all the Hangman images are Hangman 0, so 0 incorrect, 1 incorrect, 2 incorrect, 3 incorrect in the Hangman builds. And then we have a Hangman underscore lose, Hangman underscore win. So it doesn't seem important right now maybe, but it will come in handy when we get into how the images are loaded. So let's take a look at the main program. So if you're even an intermediate or beginner programmer, you know that we always have a main function that runs a program. And ours is just one line. Yeah. After we finish our coding in the other files, we are literally going to have one line of main program. And all it does is create a new GameBoard. Again, not the way you have to write it, just the way I wrote it. So, my idea is to start with the smallest elements of the game, the letter tiles and the Hangman tiles, and then we'll work our way up to the GameBoard, which has all the logic of the game. So, I'm going to take a drink and we'll get started looking at the code. Okay, so here we have the Hangman class, and it extends the JLabel class. If you're not familiar with Java, Java has a library called Swing, and it's been replaced, or not quite replaced yet, because Swing is still used a lot everywhere. But the new graphical user interface or graphics module that's being used is Java FX. I don't know too much about Java FX, so I didn't dare to dive into it for this tutorial. But just know that these are all elements of either the Swing library, which we see imported up here, or the AWT library, which stands for Abstract Windows Toolkit. So that gives us all our graphics. And don't worry about importing all this stuff. If you work in an IDE, which stands for Integrated Development Environment, like NetBeans, as soon as you type in JLabel, it will underline this. So let's just take out JLabel real fast. I'll show you what it looks like. See, it reds underlines, and if you click on it and hit Alt-Enter, it says, there is no JLabel imported. Would you like to import it? And that's all you have to do to import something from the libraries. So don't worry about writing all that down from scratch. It'll as you type the code in, if you choose to type it on your own, it will come up. So here we see I have some Java.comments comments about the class, and it just displays a selected series of Hangman images. Wow, I already found a bug, a spelling error actually, to the GameBoard. I'll update that when I post the code. Alright, so it extends JLabel, meaning that Hangman is considered a subclass of JLabel, so it has all the attributes and methods of a JLabel. What is a JLabel? It's basically exactly what it sounds like. It's a little label, and the classic way to show images in Java, at least the way I was taught, was to always put them in a JLabel using what's called a buffered image. So if all of that confuses you, don't worry. We're going to clear it up in just a second. First thing we see are a lot of private constants, and in Java, constants are referred to as final, not const, as you might have seen in C or C++. Private just means that only this class can access these constants, which is always good. You want to keep everything private unless it absolutely needs to be public. So we have an integer here called preferred width and preferred height, and all those are the preferred width and height of the images. I think I just chose it pretty arbitrarily based on what looked good in the window. So those are, when we go set them below, you'll see that they're which numbers I use for those. This is a little more interesting. The image base name, the image directory, and the image type. I should have left that window open with the images. I'll open it back up again. You're going to see these these constants in a couple classes, and the reason is I could have made them static variables in the main class and accessed them from every other class in the package. But I thought it was best to keep things private, and so you'll see these in the letterchild class, and I think in the letterrat class too. And it's not a complex idea though. All it is the image base name, would be, for the Hangman images, Hangman, because all the images start with Hangman. The directory is the folder the images are in. Since this folder is in my actual project folder under images, I can just type images for the directory, and you'll see that below. And the type is just whether it's JPEG or PNG, and all mine are PNG, so you'll see that. Alright, moving on. So we have two private non-constants. They're just attributes of this class. And that's the path, which is a string, and the actual image, which is a buffered image. Buffered image is part of the, I think it's included in AWT, yes, right there. So you don't have to make your own buffered image class, it comes with Java. So the path is just the current path of the current image being shown, so that's pretty simple. It's just, you know, this path up here, plus the name of the image, and I just kept that, I made it its own attribute because I wanted, just in case you need to do bookkeeping, it's good to keep that path there, pretty much. You don't necessarily have to have a variable to hold the path, but I thought it was cleaner. And then we have the actual image, which is stored in a buffer image, like I said, and that will be how we render the image to the screen. This right here is our default constructor, or how we make a Hangman image without any arguments. And the default constructor, which we're not going to use in this program, and shouldn't really be used unless something, you make your own program and you need the default constructor for something. All it does is call our other constructor, which actually takes arguments for these things. So it just passes some default arguments to this constructor here. This is the meat and potatoes that we want to look at, this constructor we've written for the Hangman class. It takes an image base name, an image directory, and an image type from in order to create a new Hangman image. And so you'll see in the default constructor for the base name we pass in Hangman because that's the name that all the images for the Hangman start with. We pass in the directory, which is the folder images slash. And since that's in my project folder, that's all I have to put. However, if you put your images folder somewhere else, you'll have to include like c//my/document or /my documents/ and so on and so forth. It's probably easier to just put the images folder in your project directory and write it like so. And then .png is our image type. And that's all we need to create a new Hangman. And then we set preferred width and height here in the default our written constructor. So it's 440 pixels by 255. The base name gets set, the image directory gets set, the image type gets set. So we pass in all this information and then it gets stored in the constants for the class. And then the only other thing we need to do in the constructor is set the preferred size. And so we need to create a new dimension, pass it in the preferred width and preferred height. And then we set the path with the image directory, the image base name. This _0, that's what I was saying about the way you name things. You might have to change, if you name your Hangman images without the underscore number, you have to change that piece of the code or else it won't load the right image. Since my default image, the beginning image for me is Hangman _0, I'm adding the directory, which is images / the base name, which is Hangman _0 plus the image type, which is PNG. So it would look something like path equals images / Hangman 0.png. That's what's going to be stored in path. And then for the image, we have a function that will load the image given the path to the image. So let's take a look at that function. It's a private function. It returns a buffered image, and it has one parameter, which is the image path, which we pass to it. So I just made a buffered image here. I always set I don't know if you even have to do that in the new Java versions, but I always set my variables to null off the bat, or if it's an integer to 0 or a number to 0. It's always good to never just leave, like if I had an int, my int here, it's never good to just leave it like that. You should always initialize your variables or else garbage values get stored in them, and that's no good. If you haven't seen try or catch blocks before, this may be a little new, so I'll go over this a little bit. When we say try in Java, it means that Java is going to attempt to read this image using image.io.read. And what it does, this line, I should probably explain this line first. So image.io is another Java library function that we can use. and it's going to read. We have to create a new file, and we pass in the path that we sent it. So it's going to make a new file out of that image path, and then image.io is going to read it into our image, and that's what's going to be displayed to the screen. It's kind of a roundabout way to, you don't think about displaying an image in such a roundabout way, but that's the way we have to do it using Java. So back to the try catch thing. So Java's going to try to load this image. If something happens, maybe the image is not there, or maybe it's corrupted, it's going to catch what's called catch an input-output IO exception. And all our program's going to do is say, okay, well, if I can't load this image, I'm going to print system.err is the error log. So we're going to print load image, error image. Load image is the name of the function. And we're going to say that the image at this path that you gave me could not be found. And then we're going to exit the whole program. We're not going to go any farther. So just to test that out, let's try to mess with this a little bit and see if it works. Let's go to our main program. We'll get into this later, and I'm just going to take out the S in images, and now that path is no longer valid because there is no folder called image. So if we run our program, and we'll click test. Now we see the error being printed. Image at images.e.png could not be found, and we get the result of the program. We returned an integer to serve as an error code, and that is 1. So we're going to change that back, save, and come back to GameBoard later. So that's all that this function does. It just tries to load the image and return and throws an exception if it cannot be loaded. And then we return the image at the bottom of the function, which is stored in the image of our class, of our Hangman class. Other functions in the Hangman class include next image. So when the user makes a mistake when they're playing the game, we need to load the next image, so the head, the arms, and so on and so forth. So all I did is I wrote a load new image with a, it's a separate auxiliary function, I should say. And what it does, we'll come down here to take a look at it, is it takes a suffix, meaning what comes after the underscore. And what it does is it'll create a new image based on that suffix, and in the function above here, I'm passing it the string value of image number. So what does all that mean, Phantom? Okay, so we start out with hangman underscore 0.png. That's our default image. If the player guesses incorrectly, we need to move to hangman underscore 1. So when we need to go to the next image, I'm going to send next image the number 1, and then load. We're going to take the string value of number 1 because we need it as a string for load new image. We're going to send it to load new image. It's going to load the image directory, hangman underscore, the suffix we sent, which in this case is 1, .png. And then we're going to load that image into our hangman window. Is that all making sense so far? I hope I'm not losing you quite yet. Repaint just calls the paint component function down here, and this is actually inherited from the J component class, which is included in the Java swing. And this just tells Java how we want to render our hangman image to the window. So it could be complicated if you've never seen an override or never worked with inherited functions before, so I'll try to explain as best I can. Override means that this function is actually from a superclass, the class J component, but we're going to rewrite it for our specific custom class, which is Hangman. So this has to read exactly like this for the override to work, because this is how it's written in the J component class. This keyword here, super, means call the superclasses .paint component. So call the superclasses method paint component first. And then the graphics object is our hangman image itself, or the label that holds the hangman image. And all we have to do in paint component is call G, which is the graphics object being passed in, draw image, and then the image we want to draw, which is the image of our hangman class. I believe this is the coordinates at the top left, so 0, 0. that we want it to draw to. You can draw it to any coordinates, but this will probably work best for you if you draw it at the top left. The preferred width, the preferred height, and I can't remember, I gotta look up what this argument is. I think that is the parent component, which we don't need to. We just set it to null because we don't need it. So all this is saying is draw the current image, stored in image here, at the preferred width and preferred height in our window. One second, I'm going to cut away and I'm going to look up what that argument is so I can give you guys a good answer for that. Okay, since we're in NetBeans, I decided instead of Googling it, I'm just going to try to if you type in the graphics object and hit the, like so, I'll just demonstrate for you guys. So G and then hit period. That shows you all the available functions available to work on G. So we type in draw image, and it looks like let's see here, the last argument is image observer, and you can see all the details on the draw image function here. The observer is the object to be notified as more of the image is converted. We don't need an observer in this case, so we just leave it at null. So that's, and then the 0 and 0, the x coordinate and the y coordinate draw the image at. So I hope that clears that part up for you guys. And that does it for the Hangman class. So we're done. We're finally done with the smallest component. I hope you guys are still with me because it just gets more interesting from here. So let's go ahead. We'll leave Hangman open just in case we need to refer back to it. The other small component is the letter tiles that we saw. So I'm going to take a drink real fast. Alrighty, letter tile is pretty similar to the Hangman class except a few key differences. The first thing is we want to store whatever letter is being displayed in this class. So we have a constant image letter, and that's whatever letter is being displayed on the tile. Again, we see the image directory, the image type here. As far as what was it called in this class? The image base name we don't need because the character, the way I named my picture files, the character itself is the base name. So A, B, C, D. And so instead of having an image base name, we just have the image letter, and we're going to use that. And then we have the preferred width and preferred height, the path, and the image being rendered. So it's pretty similar to the Hangman class. Here's a key difference. We want the user to be able to interact with these images, so we add a mouse listener. We'll get into the mouse listener more in the GameBoard class, but just know that each tile is going to have a mouse listener attached to it, and it's going to quote-unquote listen for the user to click on it, and then it's going to react to that click. And that's how we work with mouse input in Java. Here's the default constructor. Again, it's just like the Hangman. We're going to pass it some default arguments and leave it at that. The regular constructor itself is also very similar to the Hangman class. In fact, if I wanted to, I probably could have made some kind of superclass for both letter tile and Hangman to derive from, but I decided to keep them separate and keep it simple. So all of this is pretty much the same as the Hangman. The height and width are the same because they're squares, and they're smaller than the Hangman, of course. The load image function is exactly the same. And we see the load new image. All this does is it adds, so say we need, we'll get into that when we get to the mouse listener. So let's take a look at guess. This is their bread and butter for the letter tile class. Guess is the function that is called when the user clicks on that tile. And what it's going to do is it's going to load new image. It's going to pass that function the string guessed. What that does down in load new image is it changes the path to the image of the guessed character, which is the one that is not filled. So instead of A, it's going to take the letter underscore and then add guessed and then .png, and it's going to load that, and then it's going to repaint the tile. This function right here, which we'll see in a second, will remove the mouse listener. I called it remove tile listener because I made my custom mouse listener for this class and I named it tile listener. It's still a mouse listener, it's just named something different. I hope I didn't lose you too much with that. And you'll notice that we actually return the image letter. We're going to return that to GameBoard, I believe, and then that's going to tell the GameBoard, it's going to give the GameBoard the character so it can decide whether the character was correct or incorrect, and then update whether the player was correct in the top left corner or add another point to their incorrect score. So that's why we're returning that character there. You'll see a lot more, and that'll make a lot more sense when we go see the GameBoard class. So we've seen load new image, and now we'll see add tile listener. All this does is it takes in a mouse listener, which we're going to pass, and then it sets this class's tile listener to that mouse listener. And it adds, this function right here is actually part of the Java swing library. And this actually attaches the mouse listener to the letter tile. So we have to use this. This is not a custom function. This is part of the swing library. And that'll activate the mouse listener on the tile. Remove tile listener does the exact opposite. It removes the mouse listener when we're done. And that makes sure that if the user clicks on the letter again, nothing will happen. And then paint component, exact same as the Hangman class. Alright, so there's our letter tiles. Now we're getting into some more complex stuff, the letter rack. So the letter rack is this whole area. I'm just going to run it so you guys can get a visual on it. This whole rectangle down here that holds all the letter tiles that we'll need. So I decided to have, 16 letter tiles in total, 2 rows of 8. And we're going to see that in the letter rack class. This class extends JPanel, which is just a subcomponent that we can store things in, graphically, I mean. So think of the whole frame of the game. This whole window is considered a JFrame. This window right here. Each of these is stored in a JPanel. So the Hangman has its own JPanel, a rectangle, these have their own JPanel, and the whole letter rack is a JPanel. So it's just subcomponents of the JFrame. I'm going to take a drink real fast. We have a couple constants in this class. How many columns we want and how many rows we want. The layout. If you're not familiar with Java graphics, this will be a little new to you. We have different layouts we can use in Java when working with graphics. This, it makes sense to use. So there's border layout, which you can set on north, south, east, or west. It makes more sense for us to use what's called a grid layout, because we're setting up our letter tiles in a grid. So it's only natural that we use a grid layout. If you want to look more into Java layouts, I recommend Googling and looking at the documentation from Oracle on layouts. They can be kind of tricky to work with, but luckily grid layout's pretty easy, especially in this case. So that's why we chose grid layout. Capacity is the total capacity, so it's basically the number of columns times the number of rows. We have 2 rows and 8 columns, so it'd be 16 in this case. We see the image directory, the image type again. The password is the password that was chosen to be guessed by the user. And I just realized I need to add a space here. There we go. And then this, the rack itself, is an array list. An array list is just if you're familiar with arrays in programming, an array list in Java is just a dynamic array. So you can add and remove very easily during runtime. So it makes things easy. You'll see a few of the operations below. And these little carets here that encompass letter tile just tell Java that the array list is going to be made up of letter tiles, our custom class up here. And we just call that rack. So again, the default constructor just passes in default values. This constructor is going to be a little different from the letter tile and the Hangman class. We're going to set the number of columns and number of rows. Again, you can set them to whatever you want, but I just chose 8 and 2 is a good number for me. Then we're going to set the layout. So we need to create a new grid layout, and all we have to do is pass the number of rows we want and the number of columns we want. It's very easy to use. This right here will set the vertical gap between the grids, I think it's between the rows actually, not the grids, the rows, to 10 pixels. So we just set a little bit of space. If we change that to 0, it looks a little crowded. I'll show you what that looks like. See, all the tiles are right on top of each other. They look like dominoes. So instead, we add 10 pixels of blank space in between them vertically. The V gap stands for vertical gap. You can also set the horizontal gap with set H gap. This spreads them out so it looks more like a game tile. So that's all that does. And then we set the capacity to 16, or the number of rows by the number of columns, which is, in this case, 16. We set the image directory based on the input that were sent, and then we create a new array list for the rack, and we set the password to the input password, which is given here. I set a little border here, an empty border around these numbers here, 10, 17, 10, 10 are the number of pixels on the, I think it's the top. Well, let's go ahead and look at it. So border factory dot create empty border. Oops, I spelled it wrong. Let's do this. It's top, left, bottom, and right. So we're just adding some blank space on the top, left, bottom, and right, all around, basically all around the J panel. If we take that out and run our program, you'll see that it also does not look great. So now the panel's kind of, it's over on this side. It's not symmetrical. There's more space on this side. It's right on the bottom. It doesn't look good. And so we add a border. I just had to experiment with values until I found something that looked good. And with the 10, 17, 10, 10, we see that the rack is more centered on the window. We got space underneath it right here, and it looks just symmetrical and nice. And we like looking nice when we're working with graphics. Last thing we do is officially set the layout to the letter rack layout, which we made up here. Set layout again is part of this Wing library. And then we call our custom function load rack. What the load rack function does is call another function build rack. So we'll take a look at that first. Alright, we start by making a string builder. If you're not familiar with Java's string builders, they're pretty useful. Strings in Java are immutable, so you cannot change a string unless you reassign it to another string. But string builders, you can add characters to them, remove characters, and they're very convenient for our purposes in this game. So we're going to make a new string builder, and we're going to pass it the password, and we're going to pass the password as all lowercase. If the user inputs a capitalized password, we don't want to mess with the capital letters and confuse the program, so we're just going to treat the entire password as lowercase and work from it like that. We create another array list of characters called tiles, and that's a new array list. We cannot, this comment here means we cannot use the primitive, I guess, char or char. I've heard it pronounced both ways. You have to use the Java capital CHARACTER in array list because they don't take primitive types. And then random is another useful library. What that does is it does exactly what it sounds like. It creates a random number or sequence for us to use. So this is where we get into some interesting logic in our program. To build the rack, what we want to do is start adding the password's letters to the rack. So say the password was Phantom, Phantom, we want to add that to the rack. And we want to make sure that we don't repeat any letters. So if our password was balloon, we don't want two L's in our tile rack. We want one L, and when the user clicks on that L, it gets rid of all the L's in the password. So if the tile list we created right here does not contain the first character, the character at index 0 in the password builder, we're going to add it to the tiles. So let's talk that through in English. What it's saying is if the tile list already has that letter, don't add it and just delete it from our string builder here, move on to the next character. If we haven't added it to the tile list yet, go ahead and add it and increment I, which keeps track of how many tiles we have in our rack so far. Makes sense so far? So basically, say the password was Phantom. We start with P. Password builder now holds Phantom, the string Phantom. Its length is, what is that? PHANTOM is 7. And so we start with a blank list of tiles. Since our tiles does not contain the letter P, we're going to add P to the tiles, and we're going to increment how many tiles are in the board. Then we're going to delete P from the password builder, so now what we have is Phantom. It goes back to the top of the while loop. Password builder.length is now 6. Now we don't have an H in the tiles yet. We add it to the tiles, we add so on and so forth until we get to the end. Password builder will be 0, and then the Phantom will be added to our tiles list. So this for loop, we have it empty because we're going to work off of I still. I is now, if our password is Phantom, I is now, PHANTOM 7. I is now equal to 7 because we incremented it 7 times as we added each letter to the tiles. While I is less than capacity, which is 16 in this case, we want to fill the rest of the rack with random letters. So we're going to start with the character C, and we're just going to set it to A, and that's just a default value. You don't have to set it to A, but that's what I did. Alright, we're going to do a do while loop here. We're going to set C to a random character between A and Z. So let's take a look at this. This might be a little bit confusing if you're not familiar with how ASCII works or how the random library works. So let's take a look and we'll see if we can't clear things up. So rand, which is the random that we created right here, has a function called nextInteger that we can use to call a random integer in a range. And this is the maximum extent of that range. So it's going to create an integer from 0 to 26, not including 26. So really we're going to get any integer from 0 to 25. And then we're going to add that to A. Since all characters in a computer are actually just stored as numbers, we can add a number to the character and it will produce the other character we want. So if, say I get the random integer 2. If I add 2 to A, we're going to get C because that's 2 more letters in A. And it just so happens to work like that because ASCII, if you're not familiar with the ASCII and you want to get familiar with programming, I definitely recommend you look into ASCII, ASCII. It's just one standardization. And it's really convenient because all the letters follow suit. All the lowercase letters anyways, from A to Z. So we can add 2 to A, the character A, and we'll get C. We can add 25 to A, and we'll get Z. Sorry about that. I can feel my voice already getting lost, but luckily we only have a few classes left. Actually, maybe one after this, but it's a big one. So, we add whatever random integer to A, we get a random letter. We cast it, this is casting it to a character. Since we're getting a number out of this, we have to tell Java, hey, I know this is a number, but I want it to be used as a character. I'm going to use that character, pass it to C, and we're going to do that while tiles contains C. So basically what that while loop does is say we have, so our password is Phantom. We've loaded Phantom into the letter rack. If we get an A from this, so say we get 0 plus A, that'll give us A. Well, our tile rack already contains A. So while it contains A, we want to do it again until we get another letter that our tiles doesn't already contain. It's just to avoid duplicates. And so we continue to do this until the capacity is filled. And now we have a letter rack that is full of the password plus a bunch of random letters. Now, the way we have the tiles list set up now, we have the tiles Phantom followed by a bunch of random letters. But we don't want Phantom to be right in a row or else the user's going to guess it right away. So now we're going to grab random tiles from that list and display them randomly. That way the user doesn't get to see the word outright. How we do that is we set I equal to 0. We make sure I is less than capacity. We increment it. And we set j equal to a random integer between 0 and the size of the tiles, in this case 16. So we're going to get a random integer from 0 through 15. And we're going to add a letter tile to the rack. Okay, I should probably go into more detail here as we get into this constructor. So we're going to add to the rack a new letter tile. We're going to pass that letter tile a random character from tiles, which we select using j. And that's going to become, over in letter tile, move up to the constructor, that's being passed in as the image letter. And then, go back here, we're also passing the image directory and the image type from this class. So that's kind of what I was talking about with keeping everything private. So instead of the letter tile being able to access the letter directory and type from the main program, we're going to pass it through the letter rack. That way it stays private and hidden. And then once we add a new letter tile with that character from our list, we're going to remove it from the list, and we're going to do that until tiles is empty and our letter rack is filled. Alright, that basically does it for the logic of how the letter rack gets filled. Let's move down here. Actually, before we get down here, we're not done with load rack yet. We called the build rack function in the load rack function, so that built the letter rack. Now we're using what's called an enhanced for loop in Java, and we're saying for every letter tile, and we're going to refer to it as a tile, in the letter rack rack, which is stored as a array list up, where is it? Right here. We're going to add that to our JPanel. Add is a function from Swing, and what this function does is it's going to add each of those images of the letter tile to our JPanel. Alright, so that's all it is. The enhanced for loop is new to, I think it came out in Java 6 or maybe 7. I can't remember where it came out, but you can use it. Just make sure you have the most updated Java version. So that's all there is for load rack. It builds the rack up, and then it takes a tile from that rack and adds it to the screen. Let's move down here. Now, for every letter tile in the rack, again, we're using the enhanced for loop. We're going to add a tile listener, and that's, again, a mouse listener. We're going to get that mouse listener from the main GameBoard class. So these two, just know that these will attach the listeners to every letter tile in the letter rack, and it will also remove the listeners from every letter tile in the letter rack. Once we get to GameBoard, we'll see how those listeners are actually implemented. Speaking of, we're now down to our final but longest class, and I just realized I left in an unused import here. Never good. I was testing out something there. I can't remember what it was. This is the GameBoard class. This is where the meat and potatoes of the logic for the game is, and it extends JFrame, meaning that our GameBoard is the window we see pop up. I'm going to take a drink here. Alright, GameBoard is the meat and potatoes of our game logic, and it's the largest class in our package. And it extends JFrame. JFrame is just a Java window, so to speak. That's a very simplified definition of it. So we're going to inherit all the attributes and methods from JFrame. We have a width and height. I don't know exactly why. This might be a good Googling project if you're very curious like I am. I'm going to do that right after I start uploading this video. I'm going to look this up. For some reason, JLabels and JPanels have a preferred width and height, but JFrames have a definite width and height that you can set. Might be because of resizing. I don't know. Anyway, good project for you guys to look up why we have set height or set size in JFrame and set preferred size and everything else. Anyway, so we have a width and height of our window. I'm also going to make it non-resizable just because I don't want it to throw off our image sizes, but you could actually implement your code so that your images stretch with the window if you want it to be resizable. We have a constant. Notice these are all constants or finals in Java. We have a final max incorrect, which is the maximum number of guesses before the game is over. The max password length, I think I made mine 15 or something like that. The Hangman image directory, the Hangman image type, and the Hangman image base name. The letter image directory, the letter image type, and the letter character will be the base name, so we don't need a base name for that. And then we have our game rack, a Hangman, and the current number incorrect. We also have a couple of JLabels. Those are the things you saw at the top of the screen. We have one for the correct, which shows the password hidden as asterisks, and it reveals each letter as it's guessed. And the other JLabel displays the number of incorrect guesses. And then we have our actual password to be guessed. And a StringBuilder for the hidden password, which is the password all in asterisks. There's something I wanted to say about... Oh, this. Again, I could have made these all static, these image finals. However, I wanted to keep it private, as I've been saying. And so this is where the customization kind of comes in for you guys. Down here is the only 3 lines where you have to put in your directory, the image type, and the base name. That will pass it to the letter rack and to the Hangman image and to the letter tiles. So if you're going to store your images in a different directory, or change the type from PNG to something else, or change the base name for the Hangman images from Hangman 0, say you just want man_0, you have to do that right here. And you won't have to do that anywhere else in the code. You just have to change it right here. And that is why I designed it that way. For those of you who are intermediate programmers, you've probably heard that static variables are evil. They are, and in this case of a tutorial, they probably wouldn't be that bad to use, but I thought I should teach you guys some good coding etiquette, so to speak. So if you're going to make any changes to the directory name or the I also just noticed that I mix these in together. Say you make a Hangman image that's a PNG, or a letter and a letter tile image that's a JPEG. You're going to have to separate this into two lines like this, equals .png, and then your letter image type equals .jpeg like that. But since they're all going to be the same, that's why I have these, that's why I have these double equals here. So this just sets the letter image directory and the Hangman image directory to the same directory, same type, and then we set the image base name for the Hangman images. Alright? Again, if you have any questions about any of this, just leave a comment and I'll do my best to explain. Sometime I can explain after I've had some time to think and I can type it out. It's better for me to explain that way, so just let me know. Let's move back up here. I'm setting my game board to 500 by 500 pixels. That's a nice size. We're going to have the max incorrect to be 6 because I only have 6 images to use for the Hangman. You can make more images if you want in your custom images and set that differently. And, I guess it's 10. I'm having a max password length of 10. Set title sets the title of the window to Phantom Hangman. We'll see that at the top. We set the size. I did set resizable to false. Did I say that earlier? I might have said that. I just didn't want to mess with the image. Yeah, I did say that. You don't want to mess with, I didn't want to mess with the images resizing with the window, but if you want to implement that, you can get rid of this line and implement it so that your images will actually stretch with the window when it's resized. Add close window listener is a custom function I made. We're going to take a look at that first. What this does is when we go up to, let's play. Also, you can see the title up here. When you go up to click the X, it'll ask you, are you sure you want to quit? And if you click no, it'll return you. Otherwise, click yes. You actually have to implement that yourself. And what we do, this is something I learned the hard way. You have to use this function, set default close operation, jframe.doNothingOnClose. You have to do that or else this will not work. The next thing we do is add a window listener. So a mouse listener listens for a mouse interaction. A window listener listens for a window interaction. And we pass it a new window adapter. And we're going to define this window. I said window adapter. Alright, we're going to add the window adapter. So with the mouse listeners, if we scroll down a little bit, I made my own tile listener class that implements mouse listener. So tile listener is a mouse listener, and I defined it within its own class. For the window listener, I didn't feel like making a whole new class for it because it's nothing too complicated. So what you can do in Java is do an inline definition. And what that means is we're going to say new window adapter, and then we're going to define our window adapter within these curly brackets here. To do that, we have to use an override. Public void window closing window event WE. You need to make sure that reads exactly like that. And here's how we get that quit dialog box to work. We make an integer called prompt, or you can call it whatever you want. We use the JOptionPane library .showConfirmDialog. This is the parent window, which is null. We don't need a parent window. This is the text we want it to show, and this is the title of the window. And Java, the JOptionPane in Java comes with a nice yes/no option, which will display we'll see the, oh wait, I guess you have to go to the main thing first. It creates a nice yes/no buttons for us. So let's do that. And then if the user, excuse me, if the user clicks on the yes option, if prompt equals yes, so this will return whatever the user clicked on, it will store it in prompt. If that prompt is equal to the yes option, we'll exit, otherwise the window will just close, and we'll go back to our game. Alright, so that's all there is for add close window listener. And then we run this function called initialize. This is stuff you would usually see in the constructor itself. You wouldn't see it in a separate function. But say we want to start a new game without closing out of the program. We don't want to have to reset all the stuff that's going to stay the same between games. Like the title of the window is not going to change, the size is not going to change. So what I did is I made a separate function that will take care of all the things that will change if you start a new game, and leave all the things that will not change, like the size of the window and all that stuff. So every time we make a new game, we're going to set the number of incorrect to 0. They're going to start with no mistakes. We're going to set the label text to word, and then colon, and then blank, which will get set once we actually build the letter rack. It'll get set to the password, only in asterisk form. We're going to set the incorrect label text to incorrect plus num incorrect. We're going to make password a new string. We're going to make password hidden a new string builder. Then we're going to call a few functions. The first one is get password. It's written down here. So this is a little more customizable than the quit dialog box that we showed before. We're going to make a string array called options. One's going to say let's play, and one's going to say quit. So these are the strings that are going to be printed on the buttons that are displayed to the user. We're going to make a new JPanel called password panel, and we're going to make a new JLabel called password label. And it's going to say enter password to be guessed. And then in the JText, we're going to make a JText field that's blank, and it's going to be set to we can pass into a JText field the maximum number of characters we want. So that's going to be the max password length we're going to pass in there. So let me go ahead and bring this up so you can see. You can see it right here. So the string options are added right here and here. Password panel is this whole little rectangle right here. I guess this would be this one right here. The password text right here, and then that text area right here. So then we're going to add the password label and password text. All that does is add these two things to the screen. And I create an integer called confirm, and I set it to -1. That's just a default value. Again, always want to set your variables. And while the password isn't empty, so that's while the variable password that we have for this class is empty, confirm equals -1. I just did that again to reset it in case it gets changed within this while loop. Confirm is going to be equal to whatever button the user decides to push. Where'd my window go? There it is. Hi, Audacity. I can see myself talk. For some reason the window is not popping up. Usually I thought it popped up like a regular window. Oh, there it is. Go ahead and quit out of that. So while the password is empty, we're going to show that option dialog. So this again is the parent component, which we leave it null. This is the panel we want to display. This is the title of the panel, if I'm correct. Yes. JOptionPane.default option means we're going to make our custom options, which we made in this array up here. So that just makes it so that we can make our own custom options. Question message sets the icon to a question mark. And then null, I need to look up what that is real fast. Alright, so null is the icon, which we don't have a custom icon, so we leave it at null. Options is the array from which we will select our options, and then option 0 is the default selected one, so you'll see that it's highlighted right here. Alright, so that's how we set up a show option dialog, and if the user clicks on let's play is the 0th element of options, and so confirm will be the number 0 will be stored in confirm. So if that happens, we're going to set the password to the text in the JText field. I almost said area, JText field. And so we set the password to the text that they have entered in. And we're going to make sure the password is only made up of letters and is less than the maximum password length. This little note here, matches is a regular expression function. If you don't know what regular expressions are, this might get a little confusing. I'll try to clear it up, but I highly recommend you look up just any general overview of regular expressions. They're extremely useful in programming. And the reason I put it's used for simplicity, not speed, is because there may be faster ways to do this matches, but this is pretty easy to do. So bear with me if you're not familiar with regular expressions. I'll try to explain it as best I can. So if the password does not, that's the not operator, I don't know if I said that before, does not match, let's look at this. This is what's called a regular expression. Within these square brackets, are the types of characters that I want to match. So any letter, lowercase a through z, any letter, oh, I just realized I have a bug here. That should be a through z, like that. Sorry about that. I had to let my brother and nieces back in. They're staying with us for a little while. So if you hear little girls screaming in the background, keep calm and code on. Oh, I noticed a little bug here with the lowercase c. It was supposed to be a capital C. So I'm glad I'm doing this tutorial. And so this looks for any letter, lowercase a through lowercase c, or uppercase a through uppercase c. Excuse me, one or more times. So we don't want a password that's empty, so we just do one or more times, that plus symbol. Excuse me. And then, or if the password length is greater than the max password length, we reject it, and we do that by showing a message dialog. So I'll bring that up so you guys can see. Let's say I do %, blah, like that. Then this message dialog comes up. So this is again null for the parent component. Password must be less than 10 characters and only contain letters A through Z. And then the title is invalid password, and it's listed as an error message. After that, we hit OK, and then we'll close out of that. And we set the password back to being empty. And so, at the end of this while loop, we go back up here. Now we see the password is still empty, and we'll go through it again until we get a valid password. All right. If if confirm equals to 1, it means they clicked the second option, which is quit, and after that, we just exit with 0. Now we can finally get into the mouse listener and tile listener. They're basically the same thing. A tile listener is just a custom implementation of mouse listener. So mouse listener, it's going to get a little complicated to explain because we're getting into the nuts and bolts of Java here. Sorry, I wanted to get the right verbiage for this. It's not an abstract class. It's a interface. So an interface is a little different from abstract class, which are a little different from regular classes. All you need to know is that implements means that we have to implement or define all the functions in mouse listener in our custom tile listener class. So what we want to do, it's located right here in this java.comment. A custom mouse listener for the letter tiles that detects when the user guesses, clicks on a letter tile, and updates the game accordingly. So that's what we want to accomplish. So when you implement an interface, you have to implement all the functions. So you'll see 4 functions down here that are actually just empty. They don't do anything because we don't care about when the mouse exits something, enters something, is released, etc. We only care if the mouse is pressed. So we're going to override this function. It has to read exactly like this. We're going to get the source of the event. So that just tells this listener that makes sure that this source is an instance of letter tile. And so, if it is an instance of letter tile, which it should be, we're going to create a character, again make it empty, an index which is E0, and a boolean called updated, which is false. So, we're going to create a new letter tile from the source. We're going to make C the result of tilePress.guess. So let's back up here a little bit. We're making a variable to hold the tile that got clicked on. That's the source, the tile that got clicked on. We're making a variable to hold that tile, and then we're calling the tile's guess function and storing the result in C. So now, that's why I said earlier that this guess function returns a character. This returns the image in the tile. Why do we want to do that? We want to make sure, we want to see if C, the variable, is part of the password. Okay, we're going to have to dissect this while loop a little bit because it gets complicated. Let's look at it. Index equals password to lowercase, index of C, comma, index not equal to -1. So let's dissect this a little bit, make it easier. So let's start with password. Password is the password we guess, of course. We're going to convert it to lowercase. We're going to say .index of, and what this does is it searches for the character C in the password starting from the index. So our index starts at 0. It's going to start from the beginning of the string. However, when we update index, we want it to start from the new index. So that's why we put that in there as a second parameter or second argument. We keep it going while we assign the result of this whole operation to index. And we keep it going while index is not equal to -1. When index equals -1, that means index of has returned -1, and that means that the function has found that the character is not in the string. So while the character appears in the string, set all the characters in password hidden, which is right now all stars, set that to the character at that index. And I think one thing that just occurred to me is I didn't go over how password hidden was set up. I'm sorry about that. Password hidden is a string builder, and we're going to append the password, but we're going to replace every character in the password with asterisks so that it appears at the top of the screen as all asterisks, kind of like how your passwords are entered. And we're actually using regular expressions here. So if you haven't worked with regular expressions, this probably looks a little weird. We're replacing all periods with stars? No. What period is in regular expressions is any character. It represents any character. It's called the a wildcard character is the period. So we're replacing all the characters in password with stars, and then we're going to store that in password hidden, which is displayed at the top left of the screen. And then we set the text of the correct J label to whatever the text was incorrect plus the new hidden password. So we started in the correct, where is it? The correct J label started with word colon, and we're just going to add the password and asterisk form to the end of that. That's all that's saying. Now we can get back down to our tile listener. So once we get the character, we're going to set the character at the index we found to the character that the player guessed because it was a correct guess. And then we're going to increment the index so that we start from the character in the password right after the one we just set. And we're going to set updated to true, which will come in handy down here. If something was updated, I guess it's worth noting too, if the letter does not appear in the password, this will return -1 on the first try, this will not execute at all, and updated will stay false. So let's say the guess was correct. If it was correct, updated will be true. If updated, will render true. We're going to set the text to the word plus the new password hidden. And then if the password hidden now equals the password, we're going to remove all the listeners on the letter tiles. We're going to set the Hangman image to the winning game image, and we're going to start the new game dialog. I don't think, I skipped some stuff in this, didn't I? I skipped over the lose image and the win image. I skipped right over it. I'm sorry, guys. All they do is, since I named my files Hangman Win, or Hangman_win and Hangman_lose. Oops, it's kind of cut off there. All we have to do to paint the new lose image or win image is call. I'm losing it, guys. It's been a long tutorial. Is call load new image with the suffix lose or win. Again, if you make your own images, you may consider naming them in this convention so that the code works easily. Otherwise, you'll have to rewrite the code a little bit to fit your needs. So we're gonna we'll go over this again since I had to backtrack there for a second. If the password hidden to string, since it's a string builder, we have to call this function first to convert it to a string. Dot equals. In Java, you cannot compare, at least it might have been updated, but I don't think you can compare a string like this. That will tell you if the string object is the exact same thing, but to actually test if one string is a clone of the other, you use the dot equals function. So if password, oh my goodness, if password hidden has no asterisks in it anymore, it means the player has correctly guessed all the letters in the password. That means that password hidden will now be equal to password since we set all the asterisks to the actual characters, and that means that they won. So if that's true, that means they won. We remove all the mouse listeners so they can no longer, or they can click on the tiles but they won't do anything. We change the Hangman image to the win image, and we start a new game dialog. We'll get to the new game dialog in a second. Well, we can go over it right now. Where is it at? I think I might have skipped over it. Oh, here it is. Gosh, it took me forever to find that. It's right above it. This just if we win a game, so let's do a real quick test to run real fast. If we win the game really easily, like that, it'll send this dialog up. So can I not move that over, really? Let's see if I can move this over. There we go. There we go. Perfect. So we're going to make another dialog box. We're going to make a dialog button this time. We're going to change it to the yes/no option. We'll set the result similar to the way we did at the beginning with the with setting the password. Okay. And then if the dialog result equals yes, then we're going to call initialize again. Again, that will leave everything that needs to stay the same, or if they choose to start a new game, it'll change everything that needs to change. So, you know, the incorrect guesses will go back to being 0, and then we'll get a new password and all that. So let's test it out. If we click yes, now we get the whole password dialog again. We can do another game. Everything goes back to the way it was. Okay? That's all it is for new game dialog. And then if they press no, then we exit. Alright, so let's talk about if they did not guess correctly. Updated will be false. This if statement won't run. We'll move down to the else. We're going to set the text to incorrect plus num incorrect. If you've been programming for even a little bit, you probably know about incrementing a number like I++. What that does is it reads the number if it needs to be read and then increments it. If you put the plus before the number, it will increment the number before completing the operation. So if we did numCorrect++, the number would actually stay the same, and then the next time this is called, it would change. So we put it before so that it updates immediately. So all this does is it sets, let's run a game real fast. Twest is fine. If I guess incorrectly, it adds 1, again adds 2, and we see the picture changing, which is what we do next. Or actually, we do something else first. We check to make sure that they didn't lose. So if the number incorrect is greater than or equal to max incorrect, it shouldn't ever be greater than, but just in case, we'll add that little safeguard there. We're going to render the lose image. We're going to remove all the listeners from the tiles so they can't click on, they can click on the tiles, but they won't do anything anymore, and then start the new game dialog. Otherwise, we're going to call the Hangman that we have for our game class, and we're going to call its function, well, moving around too fast here. We're going to call the function nextImage with the number incorrect as the argument. So let's go back to Hangman real fast. If we go to nextImage, which is public, it calls the private function loadNewImage. It takes the string value of the number, so let's say we have 1 incorrect. It'll take 1, turn it into a string, load it into loadNewImage, and then it says, okay, now I want images Hangman _1. The suffix is the 1, and then it adds the underscore in the function, .png, and loads that new image and repaints. So that's what's being taken care of in the mouse listener / tile listener. Alright, with that guys, I believe that's everything we need for this game. Again, if you look into the code, you'll see, I'm gonna run it real fast for you guys so you can see what it looks like in totality. We'll play around with it a little bit. I don't think, the one thing I think I missed though is, I wanted to mention that the password it will always show the password, no matter if the player loses or wins, it will show what the password selected was. If you want to make it so that it hides the password if they lose, so they don't know what it was, you can take out that line and it will not come up. It would just say, would you like to start a new game again? Alright? I think with that, we are ready to start and play around with this a little bit. So let's do a password. We're going to choose the worst password ever password. We'll go through a winning scenario and a losing scenario. So we'll do the win one first. So when I click A, the letter tile changes to the non-filled A, the opaque A, or the transparent A rather. And I can click on this all I want, but nothing will happen. I want you to notice also that we have no repeat letters in our rack thanks to the way we wrote the code. And we have the password is randomly distributed in here with the random characters. We hit P, we hit S, we hit W, O, R, D, and we get the win screen. One thing I did want to demonstrate too, if we did password uppercase, so the code the reason we used those two lower functions when we did the logic for, seeing if it was correct, we can keep the password capital up here, and when we finish the game, oops, there we go, it will keep it capitalized. If we had used from the bat, if we had made the password lowercase and the user typed in an uppercase letter, it would still display lowercase. So I hope that makes sense what I'm trying to say. When we go to letter tile, maybe it was letter rack actually, yeah, letter rack. Is it in, yeah, 2 lowercase. That's the reason we use 2 lowercase here, so we wouldn't have to mess with capitals. We could keep the password capital if it was capital, and lowercase if it was lowercase. But we're going to do a losing scenario now, so let's just do loser. We're going to do it, so we start out with a blank, we get the head, he's got a little sweat bead on him, get a W, he's got his body there, get 1 arm, we get 2 arms. I was being pretty silly when I made these images. We get 1 leg, and then he's gone. That's too bad. Alright, so that's what the game looks like. I was on vacation when I made this, and I had a lot of free time, so and no internet access, so that's why you see the silly images and all that. So guys, that is it. Like I said, we look at our main class. The only other file you need is a main class, and all that does is just create a new game board, and that's all you need to run this program. So I hope you guys got something out of this, whether you're a beginner or intermediate, advanced, whatever level of programmer you are. I hope this was a good introduction to Java graphics for you. Again, all this was made using Java Swing. If you're interested in keeping on the cutting edge of Java graphics, definitely look into Java FX, and that's the letter F and the letter X. That's the new way of doing graphics. Otherwise, to those of you who are new programmers, thank you so much for joining me. Keep it up. If you're trying to learn programming, that's all I gotta say is keep it up. I'm so happy to see it kind of catch on lately as a hobby, not just a hobby, but a very fiery interest in all different fields for programming. And I'm biased because I'm a programmer myself, and I fell in love with it a long time ago, and I just love seeing that in new programmers, the same passion that you can take this code, this typing, and the silicone and electricity in your computer and literally make an idea a reality. I think that's pretty cool. And on that inspirational note, I'm going to sign off. I am Phantom Darkness 135. I thank you so much for putting up with my losing voice throughout this tutorial and for joining me for this tutorial. I really, really hope you guys got something out of this. I hope it's something fun that you guys were able to do. Even if you haven't programmed before, it'll give you something to tinker with. I'll give you a link to the images and a link to the code in the description for this video. They are all yours to tinker with, play with, do whatever you want with, or you can make your own images. And if you have any questions or need any resources, feel free to leave a comment, and we'll see if I or someone else in the community can get you some help. For now, I am Phantom Darkness 135. I am out of here. Take care. Program on, have fun, stay awesome, guys.